Okay, hi again, calculus students. You may have just watched a video using the quotient rule, establishing this memory fact here that I'll show again. And as we verified this trig memory fact, we use the following quotient rule that we discussed this week. If you have a numerator, function f, and a denominator, function g, both functions of x, both differentiable with respect to x, then the derivative of a quotient ends up being a big fat quotient itself, where you have a difference in the numerator and you have the square of the original function in the denominator. Okay. So let's go through some more examples using this quotient rule. Let's start with a fairly simple example. Let's let capital F of x be the quotient 2x minus 3 over 4 minus 5x. Okay. To find the derivative of capital F, we're going to use the quotient rule. The derivative of a quotient is another quotient. The denominator of the derivative is the original denominator squared. Next, we need a difference in the numerator. We're going to end up taking the derivative of the top function. We'll leave the bottom function alone, multiply. Then we will leave the top function alone and multiply by the derivative of the bottom function. Okay. Have to squeeze all that in there. Now a person has to think through the activity like I've written it out as an intermediate step. But you'll get to where you write down the result. Derivative of the numerator is 2 times the denominator minus the numerator times the derivative of the denominator, negative 5. And each step of one's scratch work, one should write down the denominator of the derivative function. Okay. Also notice that I've labeled function f, and I made sure the reader knows that this next line I'm creating my derivative. Here's Leibniz notation. Here I've actually performed the differentiation. And now I can distribute the factor of 2 through the parentheses. And maybe, not to make mistakes, maybe I'll commute this factor of negative 5, bring it to the front of the product, and change that to a positive 5 times this difference. And then we just collect some like terms. We're going to end up with an 8 minus 10x plus 10x minus 15. So let's double check my result here. I probably should have done that before I got on the video. But I might go over and do a little scratch work. 8 take away 10x plus 10x minus 15. My linear terms add up to 0, and I'm left with the constant 8 minus 15, which is indeed a negative 7. And that's the end of this. This is probably the simplest form one could write. This is the output rule for f prime. We might notice that this output is always negative, and later you'll use that to form a conclusion that the original function f is decreasing on its entire domain. But that was using the quotient rule to find the derivative of an original function that was the ratio of two linear polynomials. Okay, feel free to review that.